Do you remember Oumuamua? Picture that moment back in October 2017 when that strange, elongated visitor from deep interstellar space slipped through our solar system at impossible speed. It tumbled erratically, like a spinning shard of cosmic metal, leaving scientists stunned and silent. Its shape long and cigar-like twisted unpredictably as it reflected sunlight like a mirror. And then came the greatest mystery of all. It sped up as it left the sun, yet showed no visible tail, no gas, no dust, nothing to explain the sudden thrust. I was one of the researchers who watched those readings in disbelief. Then came Harvard astrophysicist Avi Loeb, who dared to ask the question no one wanted to hear. What if Oumuamua wasn't natural? What if it was a solar sail, an artifact, a fragment of alien engineering gliding on the pressure of starlight itself? His colleagues dismissed the idea, labeling it fantasy. The scientific community clung tightly to natural explanations. Any explanation, no matter how implausible, just to avoid the possibility of something artificial. But what if Avi was right? What if we simply weren't ready to recognize the signs? Now, 8 years later, a new messenger has arrived, 3IATLAS, the third confirmed interstellar object to cross into our solar system. And this one is doing something Oumuamua never did. Something that defies every law of celestial mechanics. Instead of accelerating toward the sun like every comet should, it's slowing down. According to basic physics, that is impossible. Pause for a moment and think about that. Natural comets always gain speed as sunlight warms their icy surfaces. The gas jets that erupt from within act like tiny thrusters, pushing them away from the sun, increasing their velocity. That's how the universe works, or at least, that's how we thought it did. Oumuamua defied us once when it sped up on its way out. But 3IATLAS is defying us again, performing micro-deceleration events, tiny, controlled braking maneuvers that have no natural cause. So the question now is unavoidable. Is 3IATLAS intentionally staying in our solar system? If so, then what we're observing right now might be the first concrete evidence of a technologically controlled interstellar object, an intelligent probe, perhaps performing active maneuvers in our cosmic neighborhood. 3IATLAS is braking gently, precisely, continuously, as if guided by purpose. And if that's true, then everything we thought we understood about visitors from the stars changes tonight. That's what we've observed in thousands of comets throughout recorded history. Oumuamua, however, broke the pattern. It accelerated away from our sun, yet showed no tail, no gas, no visible exhaust to account for the thrust. That mysterious burst of speed defied our models, challenged our predictions, and fueled years of fierce debate. But still, its motion made some sense. It accelerated outward, in the same general direction as solar radiation pressure. Now, consider what 3IATLAS is doing. It's slowing down. No natural comet in the history of observation has ever displayed sustained deceleration. The laws of physics simply don't allow it. Solar radiation pushes objects away from the sun, it doesn't hold them back. Outgassing jets eject material from a comet's core, speeding it up, never breaking it. Gravity, meanwhile, pulls inward, making objects move faster, not slower. Within the boundaries of our current celestial mechanics, there exists no natural process that can produce a braking effect on an object traveling at such velocity through interplanetary space. And yet, multiple independent observatories have confirmed exactly that. Spectroscopic velocity readings from the James Webb Space Telescope, ground-based radar tracking arrays, and Doppler shift data from orbiters around Mars all tell the same impossible story. Between September 23rd and September 26th, 3IATLAS's velocity relative to the Sun dropped from 68.2 kilometers per second to 67.9 kilometers per second. Only a minor change, 0.3 kilometers per second, but statistically, it's monumental. Natural velocity variations caused by measurement noise or atmospheric distortion scatter randomly around a mean value. What we're seeing isn't random, it's directional. A clear, sustained deceleration, consistent across multiple observation windows. Astrophysicist Avi Loeb stated it plainly in his latest analysis. This is the smoking gun. Natural forces do not cause persistent deceleration at these speeds. Either we are witnessing exotic physics beyond our current understanding, or we're observing active propulsion from a technological artifact. Consider the comparison. Oumuamua, accelerated by roughly 0.44 kilometers per second in the wrong direction. That anomaly alone was enough to ignite years of scrutiny. But 3IATLAS is decelerating by 0.3 kilometers per second in a direction that should be utterly impossible. The magnitude may be smaller, yes, but the implication is far more unsettling. Because this time, the change in direction doesn't just challenge physics, it defies nature itself. If 3IATLAS is truly slowing down on purpose, what could possibly explain such behavior? Let's explore the three most plausible hypotheses, each one more unsettling than the last. Theory 1. The reversed solar sail. Instead of harnessing sunlight to accelerate outward, imagine a reflective surface deliberately angled to catch solar radiation like a cosmic parachute, generating drag against the stream of photons pouring from our star. To function, such a system would require astonishingly precise alignment, maintaining exact angles relative to incoming sunlight, something no tumbling natural object could ever sustain. Here's where it gets even stranger. Spectroscopic analysis has confirmed that 3IATLAS possesses an unusually reflective surface, far more mirror-like than any cometary core we've ever observed. But this introduces a fatal contradiction. Natural bodies spin chaotically, tumbling in unpredictable rotations. Maintaining a fixed, stable orientation for days or weeks is physically impossible without control systems. And yet, 3IATLAS spins with mathematical precision, holding a steady posture that seems intentionally maintained. Theory 2. Undetected propulsion. Perhaps 3IATLAS is employing a form of active thrust invisible to our current instruments, some kind of electromagnetic or ion-based propulsion operating without visible exhaust or detectable radiation. It's possible that the faint green glow observed around the object's nucleus isn't cometary gas at all, but rather ionized plasma, a side effect of an unknown propulsion technology. The problem? Power. A drive system capable of altering velocity across interstellar distances would need an energy source running continuously, not for hours or weeks, but for centuries or even millennia. That kind of endurance suggests a design far beyond anything humanity has achieved. Theory 3. Gravitational manipulation. This idea suggests that 3IATLAS is using planetary flybys to subtly alter its course, not randomly, but through precisely timed encounters that exploit gravity itself as a steering mechanism. The October 3rd flyby near Mars already showed measurable changes in its velocity vector, and the upcoming March 2026 approach to Jupiter could lead to even more dramatic adjustments. But here's the problem. The timing is too perfect. Statistical modeling indicates the probability of such ideal alignments occurring by coincidence is less than 1 in 50,000. If these encounters aren't random, then we're forced to confront an extraordinary idea. All three theories reversed: sail, hidden propulsion, and gravitational control point toward a single, chilling conclusion. This isn't mindless cosmic debris drifting through our solar system. If 3IATLAS is braking, it's performing intentional maneuvers. It's not a passerby racing through space, it's slowing deliberately, methodically adjusting its trajectory, almost as if it's establishing orbit, extending its stay within our celestial neighborhood, watching, studying, for reasons we can only begin to imagine. Let's be perfectly clear about what separates 3IATLAS from every interstellar visitor we've ever encountered, because the differences reveal a deeply unsettling escalation. Oumuamua was the first, discovered in 2017. It accelerated mysteriously away from the sun, yes, but that acceleration was still directed outward, consistent with what we might expect, even if the cause was a total mystery. It displayed no tail, no surrounding coma, remaining eerily inert throughout its short passage. Its stretched, cigar-like form hinted at a natural fragment, perhaps a shard ejected from some distant planetary system. We observed it only for a few fleeting days before it vanished into the void, never to return. It showed no course corrections, no sign of control, behaving like a drifting relic, not an engineered probe. Now, fast forward to 2025 and look at 3IATLAS. It's doing the exact opposite. Instead of speeding up, It's slowing down, braking against every known physical principle, moving in a direction that should be impossible. Unlike Oumuamua, it's highly active, surrounded by a bright, structured coma with an extraordinary chemical makeup. 95% carbon dioxide, not the water vapor that dominates nearly every comet we've ever studied. Density readings indicate a potentially hollow interior, something no natural body could form through normal gravitational collapse. And unlike Oumuamua, which we tracked for days, we've been observing 3IATLAS continuously for months, and during that time, it has performed precise trajectory adjustments, threading past Venus, Mars, and Jupiter with timing so exact that the odds of random alignment are less than 1 in 50,000. Oumuamua challenged our detection systems, exposing how unprepared we were to notice such brief cosmic visitors. 3IATLAS, however, is systematically challenging our understanding of physics itself. See the progression. The first visitor, we said, that's strange. The second, Borisov, was odd but still broadly comet-like. The third 3IATLAS has crossed the boundary from strange to impossible. Even Avi Loeb's views have transformed dramatically. Back in 2017, he proposed that Oumuamua might be artificial, and for that, he was ridiculed by much of the scientific community. Now, after years of data and the extraordinary behavior of 3I, Atlas AV states plainly that this new object makes his original Oumuamua hypothesis look cautious, even conservative by comparison. According to the latest statistical modeling, the probability of a natural origin for 3IATLAS now stands between 30 and 40%, a steep drop from the initial 90% estimates. If Oumuamua was the warning we collectively ignored, then 3IATLAS is the confirmation we can no longer dismiss. In exactly 13 days, we'll know the truth. We'll discover whether 3IATLAS is simply cosmic debris or something far more extraordinary. That moment of reckoning comes during the perihelion window, between October 29th and 31st, when the object will reach its closest approach to the Sun, roughly 1.36 astronomical units, just inside Mars's orbital path. At that distance, it will endure maximum solar heating and radiation bombardment, the most intense trial nature can deliver. Ordinary comets respond to such thermal punishment in familiar ways. They fragment violently, torn apart by temperature gradients that exceed their structural strength, or they erupt into brilliant displays, forming long, radiant tails as volatile ices vaporize into space. But if 3IATLAS passes through perihelion completely intact, its survival would defy every known natural model, and the odds of an artificial origin would immediately soar to over 70%. And if it decelerates again during that passage, performing another impossible braking maneuver, then the debate ends there. At that point, we're no longer talking about a natural phenomenon. To prepare for this test, scientists have outlined 3 possible outcome scenarios. Scenario 1: fragmentation. The object shatters under the Sun's heat, scattering fragments that drift along slightly offset trajectories. Mystery solved: an exotic but natural comet, its oddities explained away by unusual chemistry and coincidental geometry. The world breathes a collective sigh of relief. Scenario 2: survival intact. 3IATLAS endures the solar onslaught without breaking apart, without shedding mass, without showing structural failure. Such resilience would strongly imply internal reinforcement, perhaps that hollow core architecture suggested by earlier density readings. The door to the artificial hypothesis swings wide open. Scenario 3: the nightmare path. 3IATLAS uses perihelion strategically, performing a deliberate orbital shift, what aerospace engineers call an Oberth maneuver. By exploiting the Sun's gravity well at peak velocity, it could redirect its trajectory with minimal energy, executing a controlled insertion into a new orbit. Such precision would represent intentional navigation, implying that 3IATLAS is not passing through, but staying, establishing a long-term presence within our solar system. After perihelion, the final prime observation window arrives on December 19th, when the object will pass approximately 167 million miles from Earth, still close enough to remain visible through amateur telescopes. By then, one way or another, we'll know whether 3IATLAS is just another piece of drifting cosmic rock, or the first confirmed interstellar visitor with intent. If the velocity readings continue indicating a slowdown, then our answer becomes undeniable. The next major checkpoint arrives during Mars 2026, when the object intersects Jupiter's gravitational influence, another chance for a course alteration. Should it perform yet another deliberate shift, any lingering doubt about its artificial nature vanishes entirely. The European Space Agency's JUICE probe will be perfectly positioned to observe this event from close range. What we're witnessing, in real time, could mark the first empirical verification of non-terrestrial technology ever recorded. Unlike Oumuamua, which slipped beyond detection before comprehensive study, 3IATLAS offers us months of preparation, a rare opportunity to observe the extraordinary, not in hindsight, but as it unfolds before our eyes. So here's the reality. An object originating from outside our solar system is behaving in a way that defies the established laws of celestial mechanics. It decelerates where physics demands acceleration. Its timing appears precisely orchestrated, where randomness should reign. Its trajectory implies long-term observation, not a fleeting cosmic passage. Regardless of whether 3IATLAS is ultimately proven natural or constructed, its existence has already achieved something monumental. It has compelled humanity to face the possibility we've long dismissed that intelligence beyond Earth may already be here, observing us from the void. The universe has never promised us simplicity or comfort, but it does promise truth if we're brave enough to look directly into the unknown. So stay tuned. Subscribe now to follow every moment of 3IATLAS as it nears perihelion. And tell us, what do you believe? Natural phenomenon or engineered artifact? Because by October 29th, the cosmos itself may answer the question that has haunted us since Oumuamua first rewrote the rules of what we believed possible among the visitors from the stars.